Hello everyone. So today we are going to talk about the general discussion about this energy and power. So let us begin the discussion from this energy. So we know well the energy is the capacity to do work, or sometime inversely what we can say is work always be done in cost of energy. That's why this energy and work are interconvertible. Okay, so we know well the unit of this energy is joule. Okay, and for our simplicity sometime we can still use the another unit, that is CGS unit of energy in terms of calorie, but this calorie term is widely used in case of heat energy. So one calorie is going to be equal to 4.2 joule, or more precisely we can say 184.18 joule. And even sometime if we need to express very small amount of energy, then at that time these units will not be much easier or will not be much applicable. So in such cases we express the energy in terms of electron volt. So another unit of energy is electron volt. So 1 electron volt corresponds to nearly 1.6 into 10 power 19 joule. So you can easily convert joule into electron volt or electron volt into joule. Okay, so let us stick with a different type of energy. So we do have different kinds of like mechanical energy. So mostly the mechanical energy can also be splitted into two parts, that is kinetic energy and potential energy. Okay, so basically kinetic energy is due to the motion of the body, or it comes by the virtue of the motion of the body, whereas potential energy is due to the state of body. The object may be in the state of rest or maybe in certain height from the surface of the earth. So at that time the potential energy of the object will be defined. Okay, so this kinetic energy basically depends upon the velocity. And you know well kinetic energy is uh, related with mass and its velocity as mv squared. So as we have seen in here, velocity is squared. That's why we can expect that kinetic energy is never negative. Okay, so kinetic energy will always be positive. Okay, always be positive. And even this kinetic energy does not depend upon any direction. So it is independent of direction, independent independent of direction. So simply it depends upon the magnitude of the mass and the velocity. Okay, so let's move on to this potential energy. So the potential energy depends upon only for the conservative field. Okay, so it depends upon conservative field. Okay, so and this potential energy can be taken to be sometime positive and sometime even a negative. So how we can differentiate, like कसरी चाहिँ छुट्याउने त कुन बेला positive हुन्छ र कुन बेला negative हुन्छ भनेर. If the energy is positive on the body, okay, on the body, then at that time that is taken as a positive. Okay, if some work is done on body, then at that time that potential energy is taken to be positive. And if the work is being done, okay, work is being done by the body, okay, by the body, then at that time the energy can be taken to be a negative. Okay, so here we have some other type of discussion for the potential energy in the gravitational field, similarly potential energy in the electric field, and so on. So in here let me just describe you a bit idea about the gravitational potential energy. Okay, gravitational potential energy. Okay, so gravitational potential energy is simply like your minus g m m by r plus h square. Okay, r plus h square. So in here you can just see the negative sign. This negative sign simply suggests us that the energy is attractive. Okay, so for attractive one we keep negative, and for repulsive it's gonna be positive. Similarly, electrostatic potential. Okay, electrostatic potential energy you can define in the same way. This is like your simply 1/4 pi epsilon naught. Okay, so this could be positive or negative. That's why let me mention this sign. This is positive or negative. If the charges are unlike, then it's going to be minus, and if the charges are like, then the potential energy going to be positive. Okay, repulsive हुने केसमा चाहिँ positive लिन्छौं. त्यसैले this is your 1/4 pi epsilon naught if the medium is air, okay, or a vacuum, and q1 q2 divided by r square. So कुनै पनि medium नलिकन generally लेख्ने हो भने in general convention this is like your plus or minus k times q1 q2 divided by r. Okay, so this is how we can write. Okay, so I think something wrong in here. This is your not square. If we just keep square there, then it's going to relate the force. Rather, we have to keep only the distance there. So this is what our energy is. Okay, so 1 by r, and in here also 1 by r. Okay, so let's move on for another. So if we are just defining this potential energy in case of capacitor, okay, in case of capacitor, then the total amount of energy deposited in capacitor will be in terms of electrostatic field, and obviously that is going to be your potential energy. So energy in there is going to be 1/2 q naught square, total energy q naught square by the capacitance. Similarly, even the energy can be stored in terms of the magnetic field in solenoids and other. Okay, so magnetic potential energy, in case of magnetic field. Okay, magnetic in solenoid. Okay, solenoid. This is gonna be your half of the self inductance times the current squared. Okay, this is how we can figure out the energy in different cases. Okay, so now let us move on further about this kinetic energy, and we know the relation for kinetic energy and momentum. So let us try to unlock that information in here. So let me just mention here, well, this kinetic energy is 1/2 mv square. So as you know this, immediately you can relate this information with this momentum. So if you simplify a bit, this kinetic energy is going to be 1/2, and let me just mention here m, okay, and square here with a v square. To manage this m, I must put it here 1m. So if you just look at the right hand side, then you can just figure out this kinetic energy is 1/2 m, the momentum square, as the momentum is mass times velocity. So this gives you the magnitude of the momentum is gonna be 2m times the kinetic energy, okay, with root. So this is the deduction that we require some time. Okay, so this is the idea for the kinetic energy and the momentum. So यहाँबाट हामी kinetic energy same हुँदा momentum कसरी change हुन्छ, अनि momentum same हुँदा kinetic energy कसरी vary गर्छ for different mass of the object, यस्तो खालको हामी MCQs हरु यहाँबाट figure out गर्न सक्छौं. Okay, so furthermore we know that the kinetic energy of the falling object, for falling object, let me mention in here, for falling object, okay, for falling object, how the kinetic energy and potential energy gets changed. Well, if the height is higher, then velocity is gonna be very high. That's why kinetic energy will vary as a function of height. And Similarly, this same kinetic energy will vary as the square of time, as a function of time. If we just want to express, then kinetic energy will be squared with the temperature, sorry, time of the flight. Okay, so this is what the idea. So furthermore, if we just discuss the other things related to this topic, to discuss MCQs, जुन म एकछिन पछाडि राख्छु पनि केही MCQsहरु मसँग छन्, ती MCQsहरुलाई डिस्कस गर्नको लागि मैले ब्याकग्राउन्ड यो प्रिपेयर गरे हो. ओके, सो क्वेशन डिस्कस गर्नुभन्दा अगाडि केही फर्दर डिस्कसन गर्छु. सो हामीलाई थाहा छ कहिलेकाहीँ यो क्वेशन्सहरु बम एक्सप्लोजनको केसहरुको पनि सोधिन्छ. सो इन केस अफ बम एक्सप्लोजन, ओके, हामीलाई थाहा छ बम एक्सप्लोजन भन्नुको मतलब पहिले रेस्टमा थियो, त्यसपछि यसका फ्र्यागमेन्ट्सहरु मोसनमा जान्छन्. सो अभियसली काइनेटिक एनर्जी हुन्छ. त्यसैले मानौ यसका दुईटा फ्र्यागमेन्ट छन्, त्यो दुईटा फ्र्यागमेन्ट मध्ये पहिलो फ्र्यागमेन्टको काइनेटिक एनर्जीलाई मैले E1 लेखे भने द kinetic energy can be expressed as the mass of the first fragment divided by the total mass times total energy liberation. So यो त हामीलाई conservation of energy बाट पनि निकाल्न सकिने कुरा हो, right? त्यसैगरी E2 is gonna be, so mass of the second and M1 plus M2 into total energy. So this is how we can figure out the general idea of these all. Okay, so this is the information. Even sometime we may be asked with some of this collision type of questions. So for the collision types of questions, so let me discuss a bit, not a more thing, only a few things I'm gonna discuss in here in this box. Okay, so in case of collision, okay, sometime we can easily crack out the answers of some MCQs. Okay, so for elastic collision, okay, elastic collision, in case of elastic collision, if your masses are equal, like M1 equals to M2, then how we can figure out the velocity is, if the initial energy is U1 and V1, then immediately they will exchange velocity. That means finally after collision, सुरुको object को V1 भइदिने र दोस्रो object को U1 जति हुन्छ. So they will exchange the magnitude of the velocity. Okay, so त्यसैगरी यही केसमा if we have initial velocity of the first object is 0, like your initial velocity is 0 and velocity of the new case. Okay, so after elastic collision दोस्रोको velocity केही छ भने त्यो object को velocity चाहिँ, so this V1 is gonna be 2 M2 U2. We can just do a small mathematics to figure out this. I just directly wrote in here. Okay, M1 plus M2 हुन्छ. Okay, त्यसैगरी फेरि हामीसँग अर्को सिचुएसन पनि हुन सक्छ है, जस्तो M1 equals to M2 पनि छ. त्यसैगरी initial velocity of the first 0 छ भने यस्तो केसमा simply हाम्रो V2 is V1 is gonna be equal to velocity of first is gonna be equal to the final velocity of the second. Okay, initial velocity of the second. Okay, V1 is gonna be equal to U2 and the velocity of second is going to be 0. यो यहाँबाट पनि हामी बुझ्न सक्छौं इलास्टिक कोलिजन को केसमा मास बराबर हुँदा एक्सचेन्ज गर्छन् यिनीहरुले है, भेलोसिटी एक्सचेन्ज गर्छन्. यो भयो जेनरल आइडिया. अब यसको भन्दा पछाडी म अब फर्दर डिस्कसन चाहिँ योसँग रिलेटेड एमसीक्यूज को डिस्कस गर्छु. सो लेट अस मूव अन टु दैट डिस्कसन. Okay, shortly I'll bring you the. So okay, in here I have kept some MCQs based on the information that I've just discussed. Okay, so यहाँ सोधेको क्वेशन्सहरु चाहिँ प्रिभियसली काहीँ न काहीँ मेडिकल और इन्जिनियरिङ इन्ट्रान्स एक्जामिनेसनमा सोधेको छ. I already have mentioned where this question had been asked previously. So suruko question hero. So the kinetic energy of the body of mass m is E, the linear momentum. Okay, so you एकदम straightforward type of questions. Let me discuss a bit in here. So अघि पनि मैले अगाडिको डिस्कसनमा यो गरेको छु. Okay, so हामीलाई थाहा छ kinetic energy 1/2 mv square हो. Okay, so यसैलाई अलिकति दुई लाइन अरेन्ज गर्ने हो भने so we can finally come back to the relation of momentum that I just discussed early. So यहाँबाट हामीले momentum को भ्यालु कति निकाल्न सक्छौं भन्दा 2m अनि kinetic energy को under root. So यस्तो निकाल्छौं भने so यो root भनेको 1/2 छ. So kinetic energy को ठाउँमा यहाँ e दिएको छ. त्यो भएको हुनाले simply हामी कति लेख्न सक्छौं त यो चाहिँ हाम्रो करेक्ट आन्सर हो भनेर फिगर आउट गर्न सक्ने भयौं. ओके, सो लेट अस मूव अन टु सेकेन्ड नम्बर. टु आइडेन्टिकल ऑब्जेक्ट्स balls of A and B are moving towards each other with velocity 5 meter per second and minus 3 meter per second respectively. They undergone head-on collision. The velocity after collision is okay identical भनिसकेपछि मास पनि सेम छ, साइज पनि सेम छ, सबै कुरा सेम छ भने अघि मैले फर्दर अगाडि डिस्कस गरेको थिएँ कि यदि यस्तो खालको सिचुएसन है हेड अन कोलिजन छ, इलास्टिक टाइप अफ कोलिजन छ र identical mass छ भने they will exchange their velocity. So the velocity of A is going to be 3 with minus and the velocity of this is going to be plus 5. Okay, so third is furthermore the kinetic energy of the body is increased by 2 times, then the momentum increase is okay. So again this is the mathematical relation. So I already have seen previously हामीलाई थाहा छ kinetic energy is directly proportional to p square. Okay, so kinetic energy so यसरी हामीले निकालेको थियौ नि kinetic energy equals to 1/2 m p square. Okay, so kinetic energy directly proportional यो mass constant छ भने हैन. अब यस्तो बेला के गर्ने त यस्तो बेला सिम्पली यसको लजिकल क्याल्कुलेसन गरौँ. सो kinetic energy के भएको छ भन्दा kinetic energy is 2 times the kinetic energy of the body is increased 2 times. Okay, so यसलाई म अलिकति यहाँ ब्रिफली क्याल्कुलेट गर्छु. सो हामीलाई थाहा छ kinetic energy 1 by kinetic energy 2 is that both of these are proportional. That's why I can write p1 square by p2 square. Okay, so if you just take the square root on each side, the situation will be like this one. Okay, so kinetic energy is double in second case. This is going to be 1/2. So your magnitude 1/2 हुन्छ भने this is going to be p1 by p2. So यसलाई simplify गर्ने भने this is p2 is going to be here is root 2 times the p1. So kinetic energy double गर्ने हो भने momentum is going to be increased by root 2 times. Okay, so this is how we can easily figure out the information regarding this one. So this is your correct answer. So number 4, two bodies of different mass possess same momentum. Momentum दुवैको बराबर छ. Which possesses the greater kinetic energy? So हामीलाई थाहा छ अघिकै इक्वेसन फेरि है. So time and again त्यही इक्वेसन हामी युज गरिरहेका छौं. हामीलाई थाहा छ kinetic energy is p square by 2m, right? So हामीलाई थाहा छ. So यहाँबाट हेर्ने हो भने kinetic energy is proportional to 1/m. 1/m हुने भयो. Okay, kinetic energy 1/m हुन्छ भन्नुको मतलब smaller the mass, more the kinetic energy if momentum is same. Okay, so same momentum यो p constant राखेको छ. If the momentum is constant, then we can say this. Okay, so which one is gonna be gonna have the more kinetic energy? So definitely the smaller one, the lighter object. Okay, so let us move on to another question. We do have here in collision. So it doesn't have said the type of collision. जुनसुकै पनि हुन्छ है. collision मा के चाहिँ हुन्छ है. collision मा सबै collision मा के हुन्छ त momentum conserve हुन्छ. यो हामीलाई थाहा छ है. only kinetic energy is conserved. यो त हाम्रो सिचुएसन जरुरी छैन कि सधैं चाहिँ kinetic energy मात्रै कन्जर्भ हुनुपर्छ है. both kinetic energy and momentum conserve. जस्तो inelastic collision छ भने यो हुँदैन है, collision मात्रै भनेको छ हामीले क्वेशनले, collision मात्रै भनेको हुनाले यो जरुरी छैन, inelastic collision मिल्दैन. Kinetic energy is always conserve, जरुरी छैन है, सधैँ भनेको छ kinetic energy सधैँ conserve हुँदैन नि, नहुन सक्छ नि है. सो सधैँ conserve हुने चाहिँ के हो त भन्दा इलास्टिक होस् इनइलास्टिक होस् यही मोमेन्टम हुन्छ. त्यो लर्निङ अन्डरस्ट्यान्डिङ बाट आइहाल्छ. Which of the following is always conserved in collision? सधैँ conserve हुने भनेको फेरि आन्सर यही हो. सो कोलिजन यहाँ अलिकति इन कोलिजन भनेको छ, कहिलेकाहीँ झुक्किने सम्भावना हुन्छ यो अप्सनमा है. जरुरी हामीले कोलिजन भन्ने बित्तिकै सबै खालको कोलिजनसँग मिल्ने खालको खोज्नु पर्यो. यो क्वेशनले यहाँनिर फेरि सोधेको छ, which of the collision is always conserved. अब क्वेशनमा अलवेज आछ, योसँग हामी स्टिक भएर फिगर आउट गर्नु पर्यो. सधैँ कन्जर्भ हुने के हो त, इलास्टिक होस् इनइलास्टिक होस् एडन होस् सुकै कोलिजनमा लिनियर मोमेन्टम चाहिँ कन्जर्भ नै रहन्छ राइट. त्यो भएको कारणले हामीले यो आन्सरलाई यहाँनिर राख्न सक्यौं. ओके, लेट अस मुभ अन टु अदर क्वेशन्स. सो इन हियर further set of question is arrived. So in here you are being asked to calculate something like this one. So a train is moving with the velocity v1 and another train is moving with velocity in same direction. Just to भनौं न, यो v1 ले हिँड्दैछ अर्को यो v2 ले हिँड्दैछ, they are moving in same direction. Okay, in same track. If the difference between them is a, okay, मानौ यिनीहरुको बीचको डिस्टेन्स चाहिँ a छ. A, the minimum retardation of the train so as to avoid collision. Collision चाहिँ हुन दिनु भएन, यिनीहरु सँगसँगै हिँड्दैछन्, हामीले कतिको रिटार्डेसन डेभलप गर्ने हो भने चाहिँ यिनीहरु कोलिजन हुनबाट बच्छ होला त है. अब यो क्वेशन एकदम क्रुशियल टाइपको क्वेशन देखिन्छ. सो यसलाई हामीले सजिलो तरिकाले गरौँ है. सजिलो तरिका हाम्रो के छ भन्दा हामीले पढेको इक्वेसन छ v स्क्वायर इक्वल्स टु u स्क्वायर प्लस 2as है. यहाँबाट हामी फिगर आउट गर्न सकिहाल्छौं. ओके, सो लेट अस से दिस थिंग्स इन हियर. So यसलाई म यहाँनिर सिम्प्लिफाई गर्छु. Okay, let me use another color so that you can differentiate it well. Okay, so यहाँ म के गर्न सक्ने भए भने, so यिनीहरुको रिलेटिभ भेलोसिटी चाहिँ कति, रिलेटिभ भेलोसिटी इज v1 minus v2. This will be acting as a velocity. Okay, and distance is a and retardation is r. Okay, so retardation 0 गर्यो भने त यिनीहरु कोलिजन भइहाल्छ. That's why मैले के गर्नु पर्यो भन्दा retardation should be greater than 0. Okay, let me just write in here, space अलिकति बचाएर राखौं. Okay, so त्यसो भए मलाई थाहा छ v square equals to u square plus 2as. Okay, so v square must be greater than 0. यो 0 भन्दा ठूलो हुनु पर्ने. Okay, यो 0 भन्दा ठूलो हुनको लागि I just must put in here 0. This should be greater than 0 and u like is your initial velocity. So this is v1 minus v2. यति velocity ले हिँडिरहेछन् minus 2 into retardation. Instead of this acceleration, I just write retardation, and the distance travel is a. So if you just simplify this thing, if you bring this r this side, then what you're gonna get is retardation is greater than or equal to v1 minus v2 square divided by 2a. So what is the answer in here? This one. This one is going to be the correct answer. Okay. अब यहाँ झुक्किने प्रब्लम सम्भावना कहाँ देखिन्छ भने v1 minus v2 किन लिन त भन्दा each and every time यिनीहरु दुईटाको बीचको भेलोसिटी कति रहन्छ त, यो भेलोसिटी रहन्छ. यही भेलोसिटीले उनीहरुको बीचको रिलेटिभ भेलोसिटी डिटरमाइन गर्ने हुनाले हामीले इनिशियल भेलोसिटीलाई चाहिँ यो v1 minus v2 को टर्ममा लियौं, और इनिशियल भेलोसिटी जस्तो चाहिँ रिलेटिभ भेलोसिटी हुने भयो. Okay, so this question is very interesting. Okay, so this is the idea about this one. Now for the questions, a body of mass m is moving with velocity v and gets splitted into two halves, two parts, such that m by 4 come to rest initially. Okay, what is the kinetic energy of the other? Okay, so interesting. एउटा दुईटा पार्टमा टुक्रा भइरहेछ, एउटा रेस्टमा आइसक्यो, अर्को पार्टको भेलोसिटी कति होला. अब यसलाई हामी कन्जर्भेसन अफ लिनियर मोमेन्टमबाट गरौँ. हामीलाई थाहा छ ल दुईटा पार्टमा एउटा m by 4 हो. ओके, दिस इज m by 4. अर्को कति हुन्छ त, अर्को हामीलाई थाहा छ m टोटल m by m minus m by 4. यति नै हुने हो रिमेनिङ पार्ट. ओके, दिस इज योर m1 and this is gonna be the m2. Okay, m1/4. मानौ यसको भेलोसिटी कति छ v dash छ, टोटल मोमेन्टम के हुने 0 हुने, रेस्टमा छ नि। ओके, रेस्टमा भएको बडी स्प्लिट भइरहेछ, सरी बडी विथ मास दिस एन्ड स्प्लिट्स इन्टु 2 हाफ्स। ओके, यस्तो छ। अब यसको भेलोसिटी यो v dash निकाल्ने हो भने दिस v dash इज गोइङ टु बी 4/3 अफ v। ओके, यो चाहिँ यो रेस्टमा गइसकेको छ, m/4 रेस्टमा गइसकेको छ। ओके, सो अब यो v dash को भ्यालु निकाल्ने भने 3/4 अफ v हुने भयो। ओके, सो यहाँबाट काइनेटिक एनर्जी अफ सेकेन्ड निकाल्ने हो भने 1/2 मास कति, सेकेन्डको मास भनेको 3/4 अफ m, अनि भेलोसिटी कति, भेलोसिटी भर्खर हामीले निकाल्यौं 4/3 अफ v। सो यसलाई सिम्प्लिफाई गरेर हेर्ने हो भने सो दिस इज गोइङ टु बी योर 2/3 m of v square. So this is how we can easily get the value of 2/3 mv square. Okay, so let us move on to another question. So where it is asked about this, a force of this x on the particle in x direction, where f and x are in their SI units, how much work is done when for the force displacement starts from 0 to 2. So 0 to 2 भन्ने बित्तिकै यहाँले हामीलाई लिमिट दिएको है, लिमिट दिएको, अनि यो लिमिटमा हाम्रो यो फोर्सले डिस्प्लेसमेन्ट, यो फोर्सले डिस्प्लेसमेन्ट गराउँदैछ। हामीलाई थाहा छ वर्क डन भनेको सिम्पली वर्क डन इक्वल्स टु फोर्स टाइम्स डिस्प्लेसमेन्ट। अब यहाँनेरि 0 देखि 2 सम्म डिस्प्लेस गराइरहेको हुनाले लेट अस इन्टिग्रेट, 0 देखि स्टार्ट गर्छ 2 सम्म जान्छ, यसको इन्टिग्रेसन गरौँ, यसको इन्टिग्रेसन गरौँ है। यसको इन्टिग्रेसन गर्ने हो भने सिम्पली हामी निकाल्न सक्छौं कि यसको भ्यालु कति हुन्छ, इन्टिग्रेट गर्ने f dx। ओके, यो dx हुन्छ भने इन्टिग्रेसन अफ 10 प्लस 5x। ओके, इन्टिग्रेसन 0 to 2, सो यसलाई इन्टु dx। ओके, 0.5x इन्टु dx गर्ने नि x स्क्वायर बाइ 2 आउँछ, यसलाई सिम्प्लिफाई गर्दै जाने फाइनली यु आर गोइङ टु गेट दिस 21 जूल। ओके, सो यस्तो खालको क्वेशन पनि एक्जामिनेसनमा MCQ मा सोध्न सकिन्छ। सो यु हैव टु बी भेरी ह्यान्डी विथ दिस काइन्ड अफ माइनर डेरिभेटिभ एन्ड इन्टिग्रेसन। ओके, सो इन perfectly elastic collision, the very clearly you have to look at the words perfectly elastic collision. Kinetic energy after collision is, kinetic energy कति हुन्छ त, perfectly elastic collision मा मोमेन्टम पनि कन्जर्भ हुन्छ, एनर्जी पनि कन्जर्भ हुन्छ। सो ग्रेटर हुने चान्स छैन, स्मलर हुने चान्स छैन, सेम नै हुन्छ, 0 हुने पनि चान्स छैन है, त्यसले सेम आन्सर। A bullet of mass of 0.1 kg is fired from the rifle of mass 20 kg with the speed of 100 meters per second. The recoil velocity of the rifle must be. Okay, अब यसलाई फेरि हामी सिम्पल तरिकाले क्याल्कुलेट गर्न सक्छौं है। यसको सिम्पल क्याल्कुलेसन के हो भने the concept of conservation of momentum, यसलाई conservation of momentum बाट गर्यो भने सो सिम्पल। जस्तो मानौ न राइफल र बुलेट को भेलोसिटी, सो m1 v1 मानौ राइफल र बुलेट को सरी यो बुलेट को भेलोसिटी लिने। ओके, अनि m2 v2 यो राइफल को भेलोसिटी। सो सुरुमा राइफल रेस्टमा हुन्छ, जब यिनीहरू राइफलले बुलेटलाई फायर गरिन्छ, फायर गरिसकेपछि दुईटै कोलिज हुन्छन्, m2 प्लस m1, यो दुईटै कमन भेलोसिटीले हिँड्छ, त्यही कमन भेलोसिटी नै के हुन्छ त रिक्वाइल भेलोसिटी जस्तो हुन्छ। दैट्स व्हाई इफ यु जस्ट सिम्प्लिफाई, यो त 0 हुन्छ, और यो भनौं न यो चाहिँ 0 हुन्छ, यो राइफलको सुरुको भेलोसिटी 0 किनभने राइफल रेस्टमा हुन्छ, बुलेट मुभ गरिरहेछ हैन। त्यस्तो हुने भने यसलाई सिम्प्लिफाई गर्दा यो म्याग्निट्युड राखौं, जस्तो यो 100 छ, त्यसपछि यहाँ 0.1 छ, अनि 0.1 20 kg, यी सबै इन्फर्मेसन्सहरु राखेर हामीले यसलाई सिम्प्लिफाई गर्ने हो भने यो v जुन नयाँ भेलोसिटी हुन्छ त्यो भेलोसिटी 0.05 meter per second यो आउँछ। Okay, so you can easily do this kind of simple mathematics in there. So engineering को लागि यस्तो खालको माइनर म्याथमेटिक्सहरु हुने क्वेशन सोधिन्छ, तर कोर को क्वेशन्सहरु मेडिकल को हेर्दाखेरि चाहिँ मेडिकल को लागि चाहिँ जेनरली theoretical question or body sodheko dekhincha, त्यसैले you have to be very careful while dealing the questions. Okay, if an automobile moves with the constant power, be careful, this is constant power. Okay, constant power, and the relation between the time and velocity, the different question. Power दिएको छ, velocity दिएको छ, अनि time दिएको छ, यस्तो खालको क्वेशनमा ट्रिक हान्ने हो है। के ट्रिक हान्ने भन्दा हामीलाई थाहा छ पावर इक्वल टु फोर्स इन्टु भेलोसिटी हो। यसलाई सिम्प्लिफाई के गर्न सकिन्छ, पावर इक्वल टु फोर्स मिन्स सिम्पली मास टाइम्स एक्सेलरेसन, v by t is your acceleration and again is your v here. So यहाँबाट के गर्न सक्यो, p, okay, p by m times t, okay, equals to v square. अब यो सबै क्वान्टिटी constant हो भने I can just write p equals to, oh I'm sorry, p constant छँदैछ, p by m constant हुने हो भने I can simply write v square is constant times t. So constant times, यो constant लाई हटाइदिने भने proportionality हेर्ने हो भने v is proportional to t power 1 by 2. So the correct option is going to be this one. Okay, so this is how we have done some questions from energy and power. So I believe this completes the discussion from this chapter. If you have more questions, then you can just write down there in comment section. So we will be uploading other questions for this particular topic as well. So आजको लागि चाहिँ मैले यहाँनेरि स्टप गरेँ। So हामी नेक्स्ट डिस्कसनमा फेरि भेट्ने छौँ र मोस्ट प्रोबेबली अब हाम्रो नेक्स्ट डिस्कसन हुन्छ थर्मोडाइनामिक्स हो। फर्स्ट ल अफ थर्मोडाइनामिक्स, सेकेन्ड ल अफ थर्मोडाइनामिक्स म डिस्कस गर्ने छु। फाइनली आई विल आस्क यू टु स्टे ट्युन, लाइक गरौँ, शेयर गरौँ, ओके, अनि सब्सक्राइब पनि गरौँ हाम्रो च्यानललाई। थ्याङ्क यू अल।